You ever heard a developer say, "But it works on my machine"? Yeah, we all have. Welcome to The Explainer. Today we're going to demystify Docker, the tool that's finally putting that classic headache to rest. We're going to see how it takes the total chaos of software development and turns it into these neat, tidy packages that just run anywhere.
So, let's dive right in. What problem does Docker actually solve? Well, before containers were a thing, just getting a project up and running was a huge pain. Trying to get an entire team's computers to behave the same way, it was a constant losing battle against inconsistency.
Oh man, this is the classic, right? The age-old developer's lament. You pour hours, maybe days, into your code. It's running perfectly on your laptop, but the second it gets deployed to a server, boom, it just completely blows up. And this isn't just some random bug. It's a symptom of a much, much bigger problem. Every single computer is its own unique, kind of chaotic snowflake.
And this slide right here, it just captures that chaos perfectly. Just look at this mess. You've got one developer on a Mac, another on Windows, we have different versions of the database, conflicting versions of other services. Heck, the staging server doesn't even have Redis installed. Trying to make software work reliably across this tangled web was an absolute nightmare. It was just a never-ending cycle of, well, it works here, but not there.
So, how do we get out of this development mess? Well, this is where Docker comes in. And it wasn't just some small fix or a patch. It was a totally revolutionary way of thinking about how we handle software. It offered a surprisingly elegant solution to a really complex problem.
The magic trick behind Docker is this idea called containerization. So, instead of trying to make your Mac setup perfectly match the Linux server, which is basically impossible, Docker says, forget that. Let's just bundle the app and everything it needs, all the code, the libraries, the settings, the whole shebang, into one single standardized package, a package that just works every single time.
And here's where you can really see the genius of it. You might be thinking, isn't this just like a virtual machine? Not even close. Forget those huge, clunky VMs that have to boot up an entire operating system just for your app. Containers are so much leaner. We're talking megabytes instead of gigabytes, and they start up in milliseconds, not minutes. It's because they cleverly share the host computer's operating system instead of needing their own. It's a total game changer.
Okay, so to really get Docker, you got to understand its two most fundamental pieces: images and containers. Now, they're super closely related, but they do very different things, and getting the distinction is absolutely key. So let's unpack that.
First up, we have the Docker image. The best way to think of this is as the blueprint for your application. It's like a perfect, frozen-in-time recipe that has absolutely everything your app needs to run, all packed up and ready to go. It never changes. It's the master plan.
Then, when you actually take that blueprint and you tell it to run, what you get is a container. This is your application, alive and running. It's the house that you built from the blueprint. And really importantly, it's completely sealed off, totally isolated from everything else on your system.
And this quote just nails it, right? An image is the recipe, a container is the cake. It's the perfect analogy. And the best part is, from that one single recipe, that one image, you can bake as many identical cakes or containers as you want. This is amazing for scaling up your app or running a bunch of tests at once without them bumping into each other.
So this all sounds pretty powerful, but you might be wondering, okay, how do I actually create one of these images? Do I need to be some kind of systems genius? Well, the great news is, no, you don't. Docker makes this whole process surprisingly simple and easy to understand. It all starts with this one simple text file. It's called a Docker file. That's it. This file is basically your instruction manual for Docker. It's just a list of steps that tells Docker exactly how to assemble your image, layer by predictable layer.
And look how simple it is. Seriously, you start from a base image, maybe one that already has Node.js installed. Then you copy your own code into it. After that, you run a command to install whatever your app needs. And finally, you give it the CMD, the command that actually starts your app. 4 basic steps, and you've just perfectly defined your entire application's world.
Okay, we've got the basics down. But where does Docker really fit into the real world? Well, it's not just some handy tool for developers to play with. It is the powerhouse, the engine behind how most modern software gets built and delivered today.
This right here, this is the modern software assembly line. You might hear people call it a CI/CD pipeline. So a developer pushes some new code. An automated system instantly kicks off, builds a brand new Docker image from that code. That image gets stored away safely, and then it's deployed as a fresh new container out to the world. It's a super smooth, fast, and repeatable process, and Docker is right at the heart of it all.
So
let's bring it all home. What does this all mean for you? Well, first, it means consistency. We finally kill that "it works on my machine" problem for good. It means speed, right? It's way faster for developers to get started and way faster to deploy new features. It means isolation, so you can run all sorts of different apps on the same server without them causing trouble for each other. And maybe most importantly, it means portability. You build your app once, and you can run it, well, absolutely anywhere.
So what Docker really did was tear down all these old walls that stood between having an idea and actually making it happen. By making it so incredibly easy to build, ship, and run any application on any machine, it's just unleashed this huge wave of innovation. So the only real question left is, with all that friction gone, what amazing things are we all going to build next?